Hi, Philip. Thanks for having me. I will be talking about quarks. So, if you all remember, quarks were on the top part of our standard model image. Quarks are the elementary particles that essentially make up all the parts of the nuclei of the atoms. There are 6 flavors, which means types, of quarks, as you will see in the image. There is the up quark, which is symbolized by a U, the down quark, which is a D, the charm quark, which is a C, the strange quark, which is an S, the bottom quark, which is a B, and the top quark, which is a T. The up and down quarks are the most common in our universe, as the charm, strange, bottom, and top quarks have only been observed in cosmic rays and in particle accelerators. All 6 quarks have the same spin, but they differ from one another in masses. Because subatomic particles are so light, mass is not measured in kilograms, but by much smaller units called electron volts, which is a lowercase e and a capital V. The up quark is the lightest, having a mass of 2 mega electron volts. You can write MeV. The down quark is next with a mass of 4.8 mega electron volts. Strange is after this with a mass of 95 mega electron volts. Then charm is much more massive with a mass of 1.3 giga electron volts. Then you get to bottom and top, which are the 2 most massive of the quarks. The bottom is the next, and the bottom has a mass of 4.2 giga electron volts, while the top has a mass of 172 giga electron volts. There is much less variation in charges. The up, charm, and top quarks have charges of positive 2/3, while the down, strange, and bottom quarks have charges of negative 1/3. This is very important in understanding the charges of the particles made of quarks. All particles made of joined quarks are called hadrons, and there are 2 types of hadrons. There are baryons and mesons. Mesons are made of 1 quark and 1 antiquark, which is something that Philip will discuss later. They are more massive than most leptons, such as electrons, but are typically less massive than baryons. Mesons are always unstable and decay. Baryons, on the other hand, can be stable and are made of 3 quarks. Protons and neutrons are examples of baryons. Let's look at these examples. Protons are made of 2 up quarks and 1 down quark. Each up quark has a charge of 2/3, meaning the combined charge of the 2 is 4/3. However, when you add the negative 1/3 of the down quark, you get a total charge of the 3 quarks being 3/3, which is positive 1. That explains why a proton's charge is positive 1. Neutrons, on the other hand, are made of 1 up quark and 2 down quarks. Each down quark has a charge of negative 1/3, meaning the 2 together is a charge of negative 2/3. When you add this to the up quark, which with a positive charge of 2/3, you combine them and you get 0, which is why neutrons have no charge. This is all I'm going to say about quarks for now, but they will come up again in some later practice problems and in Sean's section on conservation laws. Hope you enjoyed.